This is called 123D Design.
I see.
It's an Autodesk product, and it's about as simple as any CAD software gets. It's very intuitive, very easy to use. So, using the example that you just mentioned of a bicycle part, let's say that we need to build a pedal for a bicycle. So these are inches here, so we'll say 2 by 3 inches, because that sounds like a reasonable size. So we'll, I don't know, round off the one end. Maybe we'll cut out so we'll take that and we will extrude the exterior portion. Let's say we'll knock it up 3/4 of an inch, 0.75. So there's our pedal, and poke a hole in it. So we have a hole punched in it now.
That's great. Wow.
So, and we'll clean up the corners just a little bit, make it a little bit prettier. So and this is free software. It's you just download it and go. And we'll just sort of round those corners off a little bit, make it look a little bit cleaner. And then with that, oh, you missed one. So grab it, tool again. Alright, so there's our pedal, and that was, 1 minute or so to sketch that up, and we export that as an STL file. STL means stereolithograph. That's the mesh file that almost all of the slicing software for 3D printers read. Yeah. I'll call it pedal, and we'll just throw it on the desktop. So there's our pedal, and I'm going to use the PowerPrint, which is the free software that comes with the PowerSpec printers.
I see.
It's not a very good piece of software, but it's free.
Good for beginners.
Right. The one that I actually use for real stuff is called it's called Simplify 3D. Now let's see what we've got on this printer now. Okay, so we've got clear material over here that's PETG, which is that's the material that like plastic water bottles are made out of and things like that. So that's on the left extruder that's loaded in through this filament tube already on that printer. So I'll just select the model, go to extruder, and use left extruder, and you see it's sort of now highlighted in that lilac color. And we'll go to print, and The material is a lot like PLA, so we're going to we're going to sort of tell the printer that it's PLA. Since we don't need a really gorgeous surface finish on this, this is what we'd call a high surface finish. This is 1/10 of a millimeter per layer.
That's perfect.
This is 0.3 millimeters per layer, so you can. I'm not sure if you'll be able to see. This
I can feel that it's like the texture is a lot more coarse.
Yeah.
That's the texture is a lot more smooth.
Yeah, you might be able to see better in this model how coarse the texture is with the lower resolution. But for a functional part like this, it doesn't matter.
It doesn't matter.
So we'll use low resolution. Now I'm using the PLA presets, but since this isn't PLA that we're actually going to use, we've got to change a couple of things. One is the PETG likes to run about 235 degrees Fahrenheit, and the build plate, the platform that we're going to build it on, we're going to run that at 60 degrees Celsius. And we're going to increase the infill. Now the infill is inside this part, it's almost hollow.
I see.
We've got 3 layers on the bottom, 3 layers on the top, 3 layers all the way around, and on the inside, it's almost hollow. We're just filling it in with as little material as we can and still keep it rigid and solid. So for things that are load-bearing or things that have a thin wall or things that we don't want to be able to see a pattern through and things like that, we'll increase the infill. This is an example of a part that was printed with 100% infill. It's a functional part. It was meant to behave in the same way as a part that was molded using injection molding processes. So all of the engineering for this part was based on the same engineering that you would use in a injection molding situation. So in order to maintain the same strength, you just print it at 100% infill. For this part, we'd kick it up to, call it 75%.
You can also reduce the wastage of material you were just doing a demo.
Correct. Going back to this part, this is just a mock-up of a radiator that I'm building for a customer. So all it has to do is look like something that we can, this is 1/5 scale. I can show it to them. I can say, this is what we're doing. This is what it's going to look like. This is,
Perfect.
Yeah, let's look at it and talk about it and see if there's anything we want to change before we build the full-scale functional part. This is a 75-cent part or $1 part to produce with a 3D printer in this scale. Once we create the real one out of aluminum, that's going to be a maybe $1,500, $2,000 part, and so it just makes sense to go through that one additional step. Looks like we're not on the platform, so we go to select that, go to on platform, and that should snap it onto the platform. So we'll try again and see what it does. So now it's slicing the model, and what it's doing there is it's taking this STL file, which is it's taking that mesh file, and it's writing all of the tool path. It's converting it to a G code, which means it's giving the X, Y, and Z coordinates of the tool head in order to build this part. Along with how much material needs to be extruded where, basically. And there's a couple of ways to sort of get it to the printer. The easy way is You just take an SD card
Yep.
and swap it over that way. This is a really clunky piece of software.
That's okay. It gets the job done. And this one you want to send it to SLA? PLA?
Well, we're only printing with the left side, so it doesn't actually matter. With a dual extrusion like this, where we're using both extruders to extrude different material in different places. You know, if we have, for example, a nylon nut that we're printing inside a softer plastic part, or something like that, then we'll specify what materials in each side. But for something like this, where we're just printing in one single material, we don't have to do anything. So it's slicing again and saving to the SD card now.